At the graphs here, we have three functions. We have f of x, the derivative of f of x, and the second derivative of f of x. We're going to kind of take a look at how these two functions, derivative and second derivative, tell us some stuff about this original function. So we can see, as we kind of move down the line, the first derivative is 1 degree less than this. Second derivative is 2 degrees less. 1 degree less each time should make sense with the derivative because we bring the power out in front and subtract by 1. Now, let's first look at our derivative function. And this is kind of like our class starter from today. We have 2 points where the derivative is equal to 0. So these are our critical values. Alright, so critical values, derivative is 0. Those could be minimums or maximums. Well, to the left of this first critical value, we have the graph above the x-axis. So what that tells us is the first derivative is positive. So if the first derivative is positive, what does that tell us about the original function? No, first derivative we're talking about here. So first derivative is positive, f is increasing. Well, let's look at the graph. This point right here, this critical value, I don't know what it is exactly, but it's right between like -1 and 0. So if we look at this graph over here, -1 and 0, there we go. At the top of that, we have a relative maximum. And to the left, we're increasing until we get there. Right, so this little blue highlight part goes with this. We're increasing until we get to that x value. Then the graph of the derivative is negative. So that means if the derivative is negative, f is decreasing. So we can see from here to the next critical value, right, between 2 and 3 right here, the function f is decreasing. And then, last but not least, to the right of that one, the derivative of f is positive again, which means f is increasing. So we can see that over here, it's increasing. When we change from a positive derivative to a negative derivative, we get a relative maximum. When we change from a negative derivative to a positive derivative, we get a relative minimum. Well, now let's look at the second derivative. Second derivative is 0 only one time. To the left of that, the second derivative is negative. So what does that tell us about f? Second derivative is negative, then the original function is just regular f. So second derivative is negative, regular f is concave down. And to the right of this value, the second derivative is positive, which tells us the original function is concave up. Well, this time we can actually tell where the second derivative is 0. It happens when x is 1. So if I look on this graph, when x is 1, it's about right there. Well, we said earlier, second derivative is negative, so f is concave down. If we look back at the original graph, you can see the blue part right here is concave down. It's opening down. But then, to the right of 1, second derivative is positive, which means f is going to be concave up. So right here, it's going to be concave up. Alright, so that's kind of the relation between derivative, second derivative, and this original. We're going to see some more of this with graphs and kind of interpreting graphs. AP Test is big on doing that, so we'll get plenty of practice as this chapter goes on.